G'day everyone, got a new design for you today. This is a 15 color 32 by 32 pixel display. So what we can do with it is that we got 15 different colors that we can represent using this special texture pack. Kudos to Matt Batwing for making that one. So we change the color of these redstone dots. For example, when they seem to make the 1, this tile changes to a blue, for example. But currently it's 0 and now it's black. So we can input the 32-bit numbers here. So currently we've selected 0, 0, which will be the very last pixel down at the very end, because it's 0 on the X and 0 on the Y. We can then select the color over here. So we can input the color of 1, for example, and then we can write to it. Now, if you can tell, I've currently got my game running quite fast. It's running at 2,000 ticks per second, to speed up the general process of making the video. In real time, however, the longest time it takes for the last pixel at the very top over there, at the very end of the machine, is only 17 seconds. So if you just speed up the game by 10 times, it would happen in 1.7 seconds, which is very fast for a screen like this. And considering the use case, and this is in a computer, for example, you kind of have to speed it up anyway for the computer to run. So as you can see, we've set the last pixel in there to white. Perhaps I want to set to something else. Well, how about actually we make a line of whites? So we'll count up in binary on the ends here. As you can see, we've made a line, a stripe. Let's change color. So we'll increase to the next one, which is this color instead. And we'll enter that. And I've got a red or pinkish color there. We can change the color again to our next line. And I've got an orange tile. So from a distance you can see it looks quite nice. These pixels aren't square, however, I will say that. It's not really possible to make them square. If we did, they'd be 3 by 3, which is a bit big. So instead I made them 2 by 3. So how it works is that you have the front little 2 blocks here, and then you have a bunch of tiles. So each tile has 14 different selectors, because we have 15 colors. One of them is 0, and the rest of them are 14. Now we have 15 because 16 is the way we represent saying that this tile's on. So if we look at this first tile here, we can see it starts here and it ends over here. So it ends at the barrel and starts the one before the barrel. How it works is that on the right here we have our on, and on the left we have our off. So if we selected in our matrix this row, this entire row, and then we selected on the bottom of our matrix this entire row at the top here, we'd be selecting all of these, and then we'd be selecting all of these on the top. And so where the point where they collide is the point we're selected. So we'll be selecting this tile here. And what we do is that our color selector is our second matrix, which will enable or disable each one. So first of all, we select this row, we select one on the bottom, and then our color matrix will select which panel we want, each different color. So if we selected this one, and then we selected the color of white, which is our very first tile here, we would disable, we would enable our off and disable our on. So we would allow the on signal and we would block the off signal. But on the rest of them, we would allow the off signal but disable the on signal. So if we selected the very first tile, we'd turn off all the other ones except for this one, this entire row. And because we only selected this middle one, this very top one here, sorry, where they both collide, we will then select this tile. So now we've selected it, we'll flick this little latch here. I could use repeaters, but the torch is actually more efficient, which will enable this redstone line here, come along here. This is a 15-bit strength, so if it is 15 of strength, which means it has to come from this tile, so torch will power that block, power the redstone. Then we subtract the amount we want from it, so we disable subtract and subtract 15 minus 14 is 1, which creates the color of white. If we move on to this one, and to be select this tile, it would power 15, come along. If it is 15, we know it's from this tile, and instead we subtract 13, so we get a select 2, which would then continue along all of these, and because of locks it won't subtract 2 minus 14, it'll keep it as 2, all the way until the end, and enable that to be the next color, which we saw was red. It's pretty large. So this design is just 32 by 32 pixels, but it's still very massive. As you can see, I've got a reasonably good computer, and it's still struggling a little bit. So it's certainly quite large. These lines here are tiled all the way from the start to the end. We've got our color matrix decoder on the side here. So as you can see, for this matrix to turn on, which means that this register line has to go off for this to turn on, we would have to have the signal of 0, 1, 1, 1, and that would be the very last number. That would be our 15th color. This one, it would have to be 1, 0, 1, 1. You see, so we've counted backwards from 1, count backwards all the way down to 0 at the very start. 0 at the very start. 0 not having 1 means it's black, which is off. On these lines here, this is our selector for our X. Now, because we've made the color selector on our Y, we don't need to make another color selector on our X. So that saves us some time. This is our X selector. This one here is our also X selector. So if we select this very first one here, it'll come all the way up to the top and power the very top lines. As you can see, it's not powering any other lines except the very top one. And then this one, which would be the next value down, will power this line, and so on and so forth, down to the bottom. So let's do practice some more with it. If we want to do this in real time, so we'll set it to real time to rate 20, which is 26 per second. Let's input the color of the very last color, which is brown. That's our maximum color. If it was this, which would be our the final color, it's the same as saying them all off, because there's no color representing all that. So this is the same as off, which is the current state, like this. So we'll set it to that. Let's input our X as 1, 2, and let's write. And because it's a bit slow, because we've set it to real time, it may take a couple of seconds to go all the way to the end and all the way back again. I'll have a timer on the screen so you can see the amount of time it takes. It won't be more than 17 seconds. There it is. So it flashed briefly because it was a 15 strength, and then it quickly realized that it was, oh, it's a strength 15, which means we subtract our amount from it, and now we have a brown tile. Yeah, that's about the end of it. Thanks for watching. See you on the next one. The raw download and Litematica in the description because people asked for both on previous videos. I'm making a computer, an 8-bit computer, to go with this soon. So stick around for that. See you in the next one. Bye.